Welcome to part 2, welcome back to space and the world of Elite Dangerous. We're halfway through our tour of the solar system, just approaching Jupiter. If you haven't seen part 1, click on the link on the video or in the description below to catch up with that. In the first half we travelled from the Sun right the way through to Mars, covering the 4 terrestrial planets, and now we're moving on to the gas giants. Jupiter, the first and largest of the gas giants, a massive ball of mainly hydrogen and helium. If Jupiter was a lot more massive, it would produce energy like the Sun by fusing the hydrogen and the helium in its core, but Jupiter is only about 0.1% the mass of the Sun. Sometimes the gas giants, Jupiter, Saturn, Uranus and Neptune, are called failed stars because they're made up of the same stuff as stars, but they're not massive enough to behave like them. Jupiter's named after the Roman god, Jupiter, king of the gods, quite appropriate as it's more massive than the rest of the planets combined. Let's go for a spin. What I'm looking for is, and can't see, is Jupiter's most famous feature, which is its giant red spot. Maybe it's around the dark side of the planet. I can't see it here. Anyway, it's a huge storm with wind speeds up to 680 kilometers an hour, that's 425 miles per hour, and it's currently about twice the size of Earth. The red spot appears to be shrinking, and some scientists have said that it will be gone entirely by the year 2030, and I've also read some other stuff that says that it won't be gone and it will last longer than that. So if you are watching this in 2030 and you have access to a high-powered telescope, preferably in low Earth orbit, if you could have a quick look this evening and then just write in the comments whether it's there or not, and then we'll know. And I'll pin the comment at the top. Jupiter is a good place to revisit Copernicus's heliocentric model of the solar system. That was the idea that the Sun is in the centre of the solar system, as I mentioned in part 1. Galileo Galilei, an Italian astronomer, sometimes called the father of modern science and the father of observational astronomy, was a big proponent of Copernicus's model. Probably the most significant discovery Galileo made was 4 of Jupiter's moons, which are collectively named after him. He first saw them in 1610 with a homemade telescope, and he noticed that over a course of a week, what he thought were stars near Jupiter were in fact these 4 moons. Here's his sketch of their positions during the week. He saw that at some points they were going the wrong way, backwards, and were therefore orbiting around Jupiter, and that meant that not everything was orbiting the Earth, just as Copernicus had argued. So that was Galileo's breakthrough in providing observational data to prove Copernicus's theory, which had up until that point just been purely theoretical. Magnifico, Galileo.
Galileo Figaro.
That was Jupiter. Saturn is next. If I can find it on this list. Flippin' heck, where is it? There it is. Galileo had a rather large falling out with the Catholic Church over the heliocentric model, and they convicted him of heresy, and he spent the last 9 years of his life under house arrest. And I thought the corona lockdown was bad. But the Vatican did finally acknowledge that he was right and pardoned him in 1992. Don't ask me what they were doing for 350 years, but must have been busy. Saturn. Named after the Roman god of wealth and agriculture, who was also the father of Jupiter, and like Jupiter, Saturn is a huge ball of mostly hydrogen and helium. The Cassini-Huygens probe orbited Saturn for 13 years between 2004 and 2017, and that's how we know most of the stuff we know about Saturn. It was named after the bloke who discovered the division in Saturn's rings, and the bloke who discovered its largest moon, Titan. Nice hair, lads. Looks like you've trained a poodle to sit on your head. Actually, I think Brian May's got that haircut. Anyway, the probe was designed in 2 parts, and the Huygens lander separated from Cassini on Christmas Day 2004 and landed successfully on Titan. We'll come back to that a bit later, but first let's get a bit closer to Saturn's rings. Wow, that's a pretty good view, I think, in my book. Gliding across Saturn's rings. But how do we know what they actually look like? Because nothing has been close enough to photograph the individual particles that make up the rings. In 1610, when our friend Galileo observed Saturn, he noticed that the planet wasn't entirely spherical. In fact, he thought it was 3 bodies, and later astronomers worked out that actually what he was seeing were the rings. And we know from this scattering of light and radio frequencies travelling through the rings that they're made up of particles ranging in size from centimetres to several metres. Particles of ice and rock. Oh, there we are, that's me, flying the ship over the rings of Saturn. Perfect likeness. Nice shot though. The most extensive ring system of any planet in the solar system. And although they're very wide, they're huge, 400,000 kilometres wide, that's the distance from the Earth to the Moon, they're comparatively thin. They're about 100 metres thick on average, that's 330 feet thick. And to show that, let's try flying through. Steady as she goes, Mr. Zulu. The Cassini probe performed a number of risky passes between Saturn and its innermost ring before crashing into the surface of Saturn in 2017. That was planned, that's how they wanted to end the mission. And that data will be analysed for years to come. Quite impressive to get between Saturn and its rings, but didn't get this close though, did it, eh? Didn't get this close. Look at that. Close enough to tag it. I wonder if we can squeeze through here, can we, without touching the sides? Ooh! Yes, nice. Graceful. Graceful. And squeaked through. Should have put some goose fat on the outside of the ship. Time to leave Saturn and its rings behind, which we can do thanks to the frameshift drive and 2 shakes of a lamb's tail.
2, 1, engage.
Wow, that's a good sense of speed and scale. We're on our way to Uranus, but performing a flypast of Titan, the largest of Saturn's moons. Saturn has at least 62 moons. And this is where the Huygens lander landed in 2004, the first successful landing on a moon other than Earth's moon. Here's a time-lapse video of its descent. The temperature at the landing site was minus 179 degrees Celsius, and the probe transmitted for about 90 minutes before, well, breaking. Titan was a prime target because it's the only place beside Earth known to have liquids on its surface. It has a thick and chemically active atmosphere, and it probably has a layer of liquid water under its ice shell surface. So it could well harbour life, Titan. Oh, hang on a minute, I've just got to let the cat in. Hang on. Hopefully it won't crash. I'm back. And we didn't crash, that's a bonus. Uranus. The only planet, apart from Earth, not to have a name from Roman mythology. Uranus was the primordial god of the sky to the ancient Greeks. And the name comes from the idea that because Saturn was the father of Jupiter, it should be called Uranus, the Latinized name for the Greek god, who was the father of Saturn. Uranus has been observed many times, but it was always mistaken for a star. It wasn't until 1781 that William Herschel observed it with his telescope in his back garden in the city of Bath in England. He actually thought it was a comet to begin with, and a number of his peers came to the conclusion it was actually a planet. And once Herschel had discovered Uranus, he became a made man, effectively. King George III gave him an annual stipend of £200. That's about £24,000 or $31,000 in modern money, and that was to become the official royal astronomer. And part of the deal was that Herschel had to move to Windsor so the royal family could look through his telescopes. I'd do that for 24 grand a year, happily. Let's go for a pootle to the other side of Uranus. We can see Uranus's rings here. All of the gas giants have ring systems. Uranus has at least 13 rings, and it's about 4 times bigger than Earth and takes 84 Earth years to orbit the Sun. About a human lifetime to get round the Sun. The planet's blue colour comes from the absorption of red light by methane in Uranus's atmosphere. Now, you may notice that I'm pronouncing it Uranus to avoid pronouncing it Uranus, which is how I remember it being called growing up. It seems to have had a rebrand as Uranus at some point. I couldn't find out exactly when, sometime in the mid-80s apparently. I suppose to avoid saying sentences like, I spent the whole of Tuesday afternoon researching Uranus. Which is true, actually, I did. But Uranus or Uranus, problems with the name of this planet go back further than that. It took over 70 years after it was initially discovered for everybody to agree to call it the same thing. Basically, because the British Empire was so stubborn. Originally, Herschel wanted to call it George's Star after his patron, King George, which is a dreadful name. And then the Swedish astronomer Erik Prosperin suggested the name Neptune, to which the English astronomers said, we'll compromise and call it Neptune, Great Britain. The name Uranus was then proposed by German astronomer Johann Bode, and his friend Martin Klaproth named his newly discovered element uranium in favour of this name in 1789, and so Uranus became the most widely used name. So that's how both the planet Uranus and uranium got their names. Despite this, the British still referred to it as George's Star until 1850, 61 years later than that. When the final bastion of the name George's Star, the HM Nautical Almanac Office, finally agreed to call it Uranus. Or Uranus. But one of the two at least. Should have called it George's Anus. Okay, so that just leaves Neptune. Neptune, here we come. I mentioned in part 1 that Elite Dangerous features a 1-to-1 scale of the Milky Way galaxy with around 400 billion stars. About 160,000 of them were put into the game based on scientific data, and the rest were created by Elite's Star Forge, which is an algorithm that creates stars and their systems. As of December 2019, the most recent data I could find, players have only explored 0.042% of the galaxy. That's an increase of 0.006% in 1 year, and at the same rate it would take over 16,500 years for the whole galaxy to be explored. So there's a lot of stuff out there. Neptune. We're far out now, 4.5 billion kilometres from where we started at the Sun. Neptune is very similar in size to Uranus, about 4 times bigger than the Earth, but 17 times more massive than the Earth, and it's named after the Roman god of the sea. Neptune is the only planet in the solar system found by mathematical prediction rather than observation, and its discovery relied on some pretty impressive maths that dramatically validated Newton's theory of how gravity works, and it was one of the most remarkable moments in 19th century science. Since Uranus had been discovered in 1781 by William Herschel, astronomers had observed that its orbit was irregular. It didn't quite appear where it's supposed to in the night sky, and some prominent astronomers at the time claimed that the reason why was that Newton's laws of gravity simply broke down this far away from the sun. Enter the French mathematician Urbain Le Verrier, who in 1846 worked intensively for months on complicated calculations that would explain Uranus's orbit. He gave his predictions to Johann Gottfried Galle at the Berlin Observatory. Is it just me, or does he look a bit like George Bush Jr.? Maybe not. Anyway, Galle found Neptune on his first night of looking for it, thanks to Le Verrier's predictions, which is pretty impressive. And it also proved that gravity doesn't break down, and we now know that it's one of the 4 fundamental forces of the universe. Let's fire up the boosters and go in for a closer look. Neptune, the coldest planet in the solar system. It can reach minus 221 degrees Celsius. The strongest winds in the solar system. Although I thought that was Uranus. The winds on Neptune can reach 2,100 kilometers an hour. It's a good job there's not a planet called Your Mama, isn't there? Because we'd be here making jokes all day. Cool, we really are out in the middle of deep space now. Although I noticed there's another traveller there, judging by the trails from their spacecraft. Now, when Neptune was discovered, it really shook up astronomy because it disproved a widely believed law of planetary positions called the Titius-Bode law. This law said that each planet would be approximately twice as far from the Sun as the one before, and it worked nicely for the 6 known planets in the late 18th century. Add the discoveries of Uranus and Ceres in the right places, and it really took off. In some part, it drove the search for Neptune itself, which it said should be here. But Neptune was found way closer to the Sun than it was supposed to be, and that was the nail in the coffin for the law. That and Ceres turning out to be just the largest of 2 million asteroids in the asteroid belt, but they didn't know that at the time. Anyway, the Titius-Bode law, not a fundamental law of nature to predict the position of planets, but rather an intriguing coincidence. So that was Neptune. That's the last of the known planets, but there is one more destination, which I'll show you on the system map. We started at the Sun, of course, and then moved through the terrestrial planets onto the gas giants, and there we are on Neptune. But we're going to end the tour even further out from the Sun, a long way out from the Sun, at a theoretical planet, which is in Elite Dangerous, which is called Persephone. There it is. And I'll tell you more about it when we get there. It's a really long way away. I'm actually going to set the location and then go and make a cup of tea, because it's going to take a while to get there. By my calculations, it's 150 billion kilometers from the Sun, I think, which makes it something like 33 times further away from the Sun than we are here at Neptune. It's a long way. So I'll see you there. Nope, not there yet. Currently travelling at 600 times the speed of light, and it's still going to take over 11 minutes. Persephone. Took a while to get here, but on the plus side, I've got a nice cup of tea now. Proper job. Something wrong with the orbital lines for some reason. Gravity might not have broken down this far from the Sun, but looks like Elite Dangerous has. Persephone in Elite is a rocky planet which we can land on, so let's do that. We've covered the 8 planets of the solar system, and we've covered the history of their discovery, but it might not be the end of the story. There might be an as-yet undiscovered 9th planet, sometimes called Planet X or Planet 9. Similar to the discovery of Neptune, astronomers have noticed the unusual clustering of orbits in extreme trans-Neptune objects. Those are bodies in orbit way beyond Neptune. And that might be the effect of an undiscovered planet. It's theorized to be 5 to 10 times the mass of Earth, and in orbit somewhere between 400 to 800 times further out than the distance from the Earth to the Sun. Actually, let's have a look. We are currently 484,504 light seconds from the Sun.
Orbital flight engaged.
As of when this video was made, there's been no discovery or observation of Planet X, but it just goes to show the search for planets with its long history continues to this day. So keep watching the skies. Here in the world of Elite, Planet X appears as Persephone, which is an icy body 10 times the mass of Earth and taking 20,000 years to orbit the Sun. Persephone was the wife of Pluto and is a commonly used name for a planet beyond Neptune in science fiction. I don't know if you remember, like me, being taught at school mnemonic, when the first letter of each word stands for something, a method for remembering the order of the planets. I've forgotten it. My very easy method just speeds up naming planets. Well, that was ruined when they relegated Pluto from the Premier League of planets to a mere dwarf planet in 2006, and they broke the mnemonic. Now it doesn't speed up naming anything. Orbital cruise complete. Glide engaged, so we're getting closer to the surface. Ship's creaking a lot. Blimey, is it supposed to sound like that? Sounds like a submarine on Silent Hunter. Come on, you bucket of bolts. Let's get down to the surface. I've never landed on anything this far out from a star before. Glide complete, so coming into the surface now. It's dark, isn't it? I can't see anything down there. Who'd have thought it this far out from the sun? It would be so dark. Where's the horizon? Oh! Oh. Well, that's the end of the tour. Oh god, I don't think I've got enough money to buy my ship back. I've only got 948,000. When your ship explodes in Elite, you have to buy it back. I don't think I've got enough money. Have I lost my ship? Okay, sorry about that. What happened was I can't fly and flew my spaceship straight into Persephone and it blew up. In Elite, you have to buy back your spaceship, and if you don't have enough money to pay for the insurance cost, which I thought I didn't, then basically you lose your ship. And seeing as I've been playing this for in excess of 90 hours, I thought I'd lost my ship. But apparently you can get a creditor's loan, which is what I've got, to make up the shortfall. I had no idea. I genuinely thought I'd lost my ship there. Anyway, we're back in the ship at the Daedalus starport, which is orbiting Mercury, quite close to where we began the tour. And even though this isn't a video where I'm doing a mission, I think I deserve one of these. We're leaving the starport in the rebought ship, thank goodness, back into space. That was a historical tour of the solar system with a unexpected ending. If you're watching this out of sequence, make sure to click on the link in the description below to watch part 1. Thanks for watching. If you like what you saw, please consider subscribing for more. It really helps the channel grow. And I'll see you in the next video.